This is the review for Exam 1, Basics of Algebra. We're going to start by filling out this addition table. And so let's look at for some of the simpler ones to do, like this one here and this one here. I can probably actually do in my head. So if you want to figure out 1/2 plus what equals 2, it's sort of like 50 cents plus what equals $2. You know it's $1.50. So this should be 3/2. If you didn't know that, you'd have to take 2 minus 1/2. And the reason for that is because 1/2 plus question mark is equal to 2. So you do 2 minus 1/2 to get question mark. And then that's going to be equal to, you're going to multiply top and bottom to get a common denominator. So remember, this is really 2 over 1. So multiply the bottom by 2 and the top by 2. And so that gives us 4 over 2 minus 1 over 2. And so 4/2 minus 1/2 is equal to 3/2. And so that's how we find this to be 3/2. We could also do this one pretty simply because it's 2/3 plus 7/3. That's going to give us this spot right here. And so we do 7/3 plus 2/3. And it's nice and easy because they already have common denominators. So 7 of these plus 2 of these is 9 of these, so 9 over 3. And remember, 9 is 3 times 3, so 3's will wind up canceling, and you'll be left with only a 3 on top. So this entry should be equal to 3. Let's do one that's not so simple, so one that doesn't have common denominators. So let's do, which one? Let's do this. So 2/3 plus 3/2. So 2/3 plus 3/2. This one's going to give us this entry right here. And so we need to find a common denominator. So what we'll do is we'll multiply 3 by 2. So we have 2 times 3 there. We'll put a 2 on top so we don't change the fraction. And then we'll multiply this by 3, top and bottom again, so we don't change the fraction. And what we get is 4, 6. Right, so 2 times 2 is 4, and 2 times 3 is 6. Plus 3 times 3 is 9, and then 2 times 3 is 6. And then 4, 6 plus 9, 6 is 13, 6. So right here goes 13, 6. What else can we do? It looks like we have to go find some more of these. So let's just pick one. Let's try to find what goes here. And so what we can do is we can use this 2/3 and this -1. So 2/3 plus this question mark equals -1. So what we can do is do -1 minus 2/3, and that'll find that question mark. Again, we have to find common denominators. So -1 is really -1 over 1. We'll put a times 3 here and a times 3 here. And so that'll be equal to -3 over 3, which notice is still -1, minus 2/3. And so -3/3 minus 2/3 is -5/3. And so this question mark should be -5/3. Okay, and let's do this last block right here. So let's try to figure out what this is. So to figure out this, we can use the 7/3 and the 9/5. So 7/3 plus question mark equals 9/5, again, because it's the addition table. So what we can do here, let's draw a line, and let's do 9/5 minus 7/3. And so we need to find a common denominator. So we'll multiply simply by 3 here, because there's a 3 there, top and bottom, so we don't change the 9/5, the fraction. And we'll multiply top and bottom by 5 here. And so what do we get? 3 times 9 is 27, divided by 3 times 5, which is 15, minus 7 times 5, which is 35, divided by 15. And so you have 27 of these minus 30 of those. So we have to do, and it's going to be all over 15. So I know it's going to be negative because you're taking away 35, and 35 is bigger than 27. So how many did you take away? Well, I usually just count down. So 5 and 3 gets me to 27. So it's going to be -8, right? Because 5 down from 35 is 30, and 3 more gives you 27. So it should be -8 over 15. That should go right there. All right, so now that we have all the entries in this column and all the entries in this row, we can find all the other blank spots by simply adding these together. So let's start here. And so to do this one, we'll take negative 5/3. And we'll add negative 18, or negative 8, sorry, over 15. All right, so we're going to add this one to this one. And it's really simple to do this one. You don't need to find a common denominator on both of them because 3 goes into 15. So we'll just do times 5 here and times 5 there. And so we'll get negative 25 over 15. And then a plus and negative is a minus 8 over 15, which is really then negative 33 over 15 because negative 25 minus 8 gives us negative 33. So it should be negative 33 over 15. We'll do the one below this. So to do the one below this, we'll take that 1/2 and we'll add it to negative 5/3. So take 1/2 and add it to negative 5/3. It doesn't matter if you put a negative sign on the top or the bottom. I usually put it on the top. That way I don't have to worry about it when finding common denominators. And so here I have to take this as 6. So I'll put a times 3 here and a times 3 there because there's a 3 there basically. And then I need to get a common denominator over here so it doesn't have a 2, so I'll put a 2 on top and bottom. And so this is equal to 3 over 6, and then plus a negative is a minus. 2 times 5 is 10, so 10 over 6. And then 3 minus 10 is a negative 7, so I have negative 7 over 6. And so that was that entry right here. So that's negative 7 over 6. We come over here to 7/3 plus 1/2. Right, so 7/3 plus 1/2. We can write that down right here. 7/3 plus 1/2 equals what? Find a common denominator. So let's see, we'll put a times 2 here, a times 2 there because there's a 2 here. And we'll put a times 3 here and a times 3 on top so we don't change the fraction. 2 times 7 is 14. 2 times 3 is 6. And we're going to add 3 over 6. And so that's equal to 14 plus 3. So we can add the numerators once we have a common denominator. So we have 17 over 6. So this one right here is 17 over 6. And then the final one we want to do is right here. And so we'll add 3/2 to negative 8 over 15. So 3 over 2 plus negative 8 over 15. So negative 8 over 15. We have to find a common denominator, so this one's not so simple, but it's not too bad. We'll multiply this by 15 on bottom and top. And then we'll multiply this one by 2 on bottom and top. Right, so that's 2 times that. So 3 times 15 is 45. 2 times 15 is 30. And then we have plus a negative 16, so minus 16, right? So 2 times negative 8 is negative 16 over 30. When you take 45 minus 16, you can count down by tens, okay? So 35, then go down by 6, and you get 29 over 30. So this should be 29 over 30. All right, and so you should check these with your calculator to make sure you did them right. And when I checked these problems, I saw that there was one, not mistake, but I forgot to reduce one of these. Negative 33 over 15 is actually equal to negative 33 is 3 times 11, and 15 is 3 times 5. So the 3's actually cancel, and you get negative 11 over 5. So I guess what I should really write here is negative 11 over 5. And the good question is to ask, why did I miss that? And the reason I missed that is because I'm not used to factoring 33. Right? 15 is 3 times 11, but I'm not used to thinking about 33 in terms of factors. And that's why it's actually so important to know those times tables, because we assume often that you know how to factor certain things, not always 33, but like 15. And so if you don't know how to factor 15, or like 6 or something, then you always get into trouble when you're trying to simplify in fractions. So do exactly what I did, because I'm not used to factoring 33, and you won't see how things actually cancel, how those 3's actually cancel here. All right, let's go on to the next problem. So on the next problem, what are we doing? So we want to consider the numbers here. So 8.52, the square root of 3, 11, negative 7/3, and negative 6, and talk about things. So which numbers are integers and which numbers are natural numbers, which are rational, irrational, and real. So you have to recall that the natural numbers are the nice counting numbers. So these are like numbers like 1, 2, 3, comma, and we'll say dot, 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 keep going on and on. Whereas the integers in this problem, they're equal to the natural numbers, 0, well, 1, 2, and 3, but also including 0, and then the negatives. So negative 1, negative 2, negative 3, dot, dot, dot. Okay, so for looking at these things, I first look at the number 8.52, and it's not an integer. Square root 3 is not an integer, but 11 is an integer. Negative 7/3 is not an integer, but negative 6 is an integer. Right, so those are all integers. But we want to take out the ones that are not natural numbers. So which one is a natural number? So 11 is a natural number, so we have to X it out. Negative 6, it's not a natural number, so you want to keep it. So there's just one answer here, negative 6. All right, so the next type of numbers we want to talk about are what? We want to talk about what are rational numbers. So let's come down here. We want to figure out which numbers are rational. So remember, rational numbers, they include all the integers, but they look like this. So they look like of the form a divided by b, such that a and b are integers, but b is not equal to 0, because you can't divide by 0 here. That's one way to write them. Another way to write them is to explain what they are, is to say they're numbers whose decimal expansions either terminate, so they end, or they do repeat. And so if you think about it in that way, this problem's not so bad. So let's take a look at 8.52. Is it a rational number? Yes, it is, because its decimal expansion terminates. Right? So when you look at it as a decimal, as it's written, 8.52, it stops. Square root of 3 does not. You can put that into your calculator if you're unsure. So you can hit the second square root of 3, and you'll see it just keeps on going and going and going and going. So the decimal expansion actually doesn't stop. The calculator, of course, stops it because it can only hold it to so many places, but it doesn't actually terminate. Okay, let's go back here. So square root 3 is out. Let's do a different color. So this is good. Of course, 11 is a rational number. Remember, 11 is like 11 over 1. Negative 7/3 is certainly a rational number, and so is negative 6. So let's write these down. 8.52 is good. 11 is good. Negative 7/3 is good, and so is negative 6. These are all examples of rational numbers. Then an example of an irrational number. Right? And the irrational number is one that's not rational. So you could say an irrational number is one whose decimal expansion either does not terminate, right, and also, though, does not repeat. Right? So rational numbers, when you look at their decimal expansions, they either terminate or they do repeat. Irrational numbers, their decimal expansions do not terminate and they do not repeat. There's only one example, of course. You just take the one that's not rational, and that is an irrational number. So square root of 3 is an example of an irrational number. And then the last one, don't be tricked by this one. So the last question says, which numbers are real? And of course, all the numbers are real. The only example of numbers that are not real are ones that involve an I, which is called the imaginary number, which is a square root of negative 1. And we didn't really talk too much about these imaginary numbers or complex numbers. So all of these numbers are real. So you want to write them all down. 8.52, comma, square root of 3, comma, 11, comma, negative 7/3, and also the number negative 6. All right, let's look at this next one, true or false. So this says negative 2. And remember this symbol. We had these symbols here. So we had, the set notation with curly brackets. So I wrote this down up here. We had that bar, which means such that. I give an example right here. We had this symbol, which means element of. So we talked about this. You could pick a student in my class and say that student is an element of my class. And we had this symbol here, which means subset of, which means contained in. So you could take all the males in my class and say all the males are a subset of my class. So this says -2 is an element, right, which means is in the natural numbers. Well, here are the natural numbers, and what you want to notice is that they don't contain any negative numbers, so this is actually a false statement. All right, you can simply make it true if you want by simply writing -2 and write that element sign and put a slash through it, so it's not an element of the natural numbers. Over here you have the real numbers, and it says the reals are contained in the rationals. So is that true or false? Well, let's write down what the reals are. So remember, the reals include all these numbers. There are two ways to kind of talk about them. One way, we just write down it's all x such that -infinity is less than x is less than infinity. Basically, they're all numbers on the number line. Right? So you can talk about this number line here, zeros in the middle, and every single pointer here represents a real number. You could also say the reals are made up of the rationals and the irrationals. But is this a true statement? The reals are contained in the rationals. It's actually false. All right, you can see this. It goes rationals, then comes the reals. So that's actually the rationals which are contained in the reals. The reals are not contained in the rationals. I mean, a good example might be something like, oh, the square root of 2 is a real number, but it's certainly not a rational number, because square root of 2 we talked about is irrational. So this is false, but you can make it true by simply saying the rationals is actually a subset, in this case, of the reals. All right, so moving on, that was number 2 and 3. And so on 4, we move on to intervals. And so for intervals, the idea is we're going to give you an interval and basically in 3 different types of notation. So interval notation, set notation, and then we'll illustrate it with a graph, and we have to be comfortable going back and forth. So the graphs are always the easiest, so let's start there. And so let's make graphs for each of these. So what does the interval 1 to 4 look like? And remember, close bracket means include, open parenthesis means do not include. So what I would do is just draw a number line, and then I would just put my numbers on here. So here's 1, and here's 4. And so this interval, what does it represent? It represents all the numbers between 1 and 4. So you shade in the numbers between 1 and 4. But you do not include 4, so you write a parenthesis, and then you write a closed bracket here at 1, which means include, do not include. Let's do it for the bottom here. This set, x such that x is greater than 5. So what does that look like? Again, just draw a number line and then try to interpret those symbols. So here's my number line. Obviously, we have the number 5 involved, so let's put 5 there. And so this set represents all x such that x is bigger than, or you can say greater than 5. So greater than 5, is that to the left or to the right? Well, that's certainly to the right, so shade in the region to the right. All the numbers to the right, x is greater than 5. And the greater than means don't put a closed bracket, but put a parenthesis, right? We don't include 5. All right, so now we have all the graphs done, and so now we should be able to write down the intervals, right, in interval notation. So this one looks like this. You start at 5 with a parenthesis, and you go all the way to the right. So you write infinity, like that. And then this one here, you have to be careful because this is -1 and this is 3. So you're going to go from -1 to 3. And then you look here, that's a closed bracket. So you put a closed bracket here, so you include 3. Whereas at -1, you have a parenthesis. So you put a parenthesis. So I always like to go from the picture to the interval notation and then to the hardest part, which is the set notation. So now to do the set notation, you can always set it up. And if you have an example, it's not too hard to sort of mimic. It's like I have something like this, such that, and then in curly bracket here. So you're going to have x such that what? Now here you have to be careful because here you have 1 and 4, whereas down here you had 5 and infinity. So you're going between 1 and 4. So 1 is less than or equal to, because it's a closed bracket, x, which is less than, remember it's less than because it looks like an L, 4. And it's not equal to because it's a parenthesis, so you do not want to include that endpoint. Down here, again, you can kind of copy down the overall structure like that, and so it's going to be x such that -1 is less than x, then is less than or equal to 3. Remember, less than or equal to because you have a closed bracket, less than because you have a parenthesis. All right, then below this, what do we have? So now we're going to do what's called the union versus the intersection of two intervals. This is pretty simple as long as you draw the picture. So the idea is just draw a picture of what these two intervals, when you union them, are actually representing. So let's do one in red. We'll do this one in red, so -infinity to 0. So you have 0 here, and you're going all the way to the left. That's what -infinity means, so all the way to the left. So there's one interval. And then you're going to take the other interval, which we'll do in green. So from -6 to 2, and you're going to include -6. So -6 is right here, so -6. All the way to 2, which is to the right of 0. And we'll shade that into green. And union means just combine them. So you just put them all together. So whatever has a color on it is going to be in your answer. So on here, if it's colored, you get to shade it in. So that has red, this has red and green, and this has green. And then this is an open parentheses, so there's no real color there. It's not including that point. So this would be equal to -infinity all the way to 2. So when you union, you just push them, the two intervals, together. The second one is an intersection. So on an intersection, you don't just push them together. You don't just join them. What you do is you look where they overlap. So again, you draw this number line. And the first interval we'll do in red. And it's -1 to 7. So -1 to 7. So here, let's put -1 here. And let's put 7 over here. And it's everything in between. And then the interval from 0 to 9 we'll do in green. And we're going to include 0, and we're going to include 9. So here's 0. It's somewhere between -1 and 7, so there's 0. And then 9 is to the right of 7. And we'll shade in the region in between. And then what we want to look at is not the union, not the joining the two, but the overlap. So where do you have two colors? So you definitely have two colors here at 0 because you have green and red. And you have green and red, so we're going to follow the green and red until we get to 7. After 7, you notice you only see green, so you stop at 7. There's a parenthesis here, so you just copy the parenthesis. And you see the intersection is from 0 to 7, and including 0. And so this is equal to, you include 0, and you go to 7. All right, so let's take a look at number 6 now. So on number 6, what do we have? So on number 6, we're going to use our calculator to crunch these numbers. You can ignore this line here. It's not supposed to be there. It's not too difficult to do if you did that calculator worksheet. And if you get stuck, you can look back at that worksheet, and I have some more videos online that sort of go through it. So take out your calculator. Let's clear this out. We can even put up show key display here. So you can follow along with me. So what we need to do on this one is we want to enter this expression right here into our calculator. Now you have to remember, you have to put parentheses on top and bottom. So here's how I would do it. I would do left parenthesis 7 plus, and then I have a square root, so I hit second x squared to the square root button. Then I hit 3. Then I hit it over to get out of the square root, and then right parenthesis divided by left parenthesis 2 times second square root, put a 5, kick it out of the square root, right parenthesis, and then hit enter. And we're going to round this to 2 decimal places. So when I round this to 2 decimal places, that 2 means you just drop off all the stuff, and you get 1.95. So this is approximately 1.95. And so that's how you do this one on your calculator. The next one, all right, so you want to enter 3e to the 2 minus 9 ln of pi. So on your calculator, what are you going to do? You don't need to add any extra set of parentheses, so you just try to put it in just like it looks. So 3, and then I always hit second ln, because behind the ln button is the e to the button, and I put a 2 up there. Then I hit over, minus, now be careful here, this is not 91, it's 9 times ln of pi. So I have 9, then hit the ln button, and then you have to go find pi. Pi is above the caret button here. So let's hit second raised to, and then in parentheses, then simply hit enter, and you get out 11.86, and because that decimal place is a 4, we'll let that just be a 6. We'll just drop this off and you get about 11.86 out. So this is approximately 11.86. All right, then for the last one, let's move this over. And again, you're going to try to put it in there as much as you can make it look the same here. And so what we have is a left parenthesis, 5, and you want to raise it to the negative 3. So use the caret button, and then make sure you use the negative button, not the minus, so negative 3. Then kick it out, so hit over, plus second x squared, because that's where the square root is, 11. Then kick it out of the square root, plus, then you have 2, and then you have to do pi, so second raised to, and then in parentheses. So that's the first expression. It looks exactly the same. And then hit second x squared to get to the square root, and then you want e cubed. So you're going to hit second ln, and then put a 3 in there, and then hit over, and then plus, and now you have the square root of 17.6, so second x squared, 17.6, hit over to get out of the square root, and then all divided by, so that's 17 squared root of 17.6 is divided by 8.3. Notice that that first square root is following you along, which it should. Right? The first square root goes all the way along. Then just kick it out. So you can see now I'm on the outside. Everything looks good. Hit enter, and out pops my answer. Now on this one, you have to be a little bit careful because when you look at the third decimal place, it's a 7. And so you're going to round that up. That 9 is going to round up to a 0, basically, and the 5 becomes a 6. So this one here is going to be 43.60. So let's break this, and so this would be approximately 43.60. Okay, so let's move on to number 7. That's how we use your calculator. And then in number 7, what do we have? Simplifying expressions. So we're going to work with exponents first, and a and b, and then we'll start working down here with radicals. All right, so remember, to do these, you have to think about, how do exponents actually work? When do you add exponents? When do you subtract exponents? When do you multiply exponents? So in this case, all of this is raised to the 1/3. So what I would do is I would raise each of these things. There's really 3 things here. This thing, and that thing. I'd raise each of these to the 1/3. So that's how exponents work. And you can remember that by simply taking like 2 to the 1 times 3 to the 1, and if you square this, what do you get? You get 2 squared times 3 squared. Because of course 6 squared is 36, which is the same as 4 times 9. So each of these gets multiplied basically by 2. We're going to do it in 2 steps though. So we'll do 8 to the 1/3. We'll do x to the negative 3 to the 1/3. And then we'll do y to the 6 to the 1/3. Right, so each of these things get raised to the 1/3, and then you still have times x squared y to the 1/3. So the next step then is what do you do with these exponents? And so 8 to the 1/3, you have to remember, is actually the cube root of 8. So remember, if when you have a fractional exponent, the top part is the nice thing. It's the power, so it's like 8 to the 1. And then the thing in the denominator is actually the root. So that's the cube root. So the cube root of 8 is actually 2. So you get 2 here. Times, and then here you have a negative 3 and a 1/3. And so you have to remember that here you don't add exponents, you actually multiply. So you're going to get x to the negative 1 because the 3 is going to cancel. 3 times 1/3, the 3's cancel, and you're left with a negative 1. Remember, I know to multiply exponents here because if you took, let's something like 2 to the 1 and you squared it, this would certainly be 4, which is 2 squared. And so obviously you don't add exponents, you multiply. 2 times 1 is 2. We'll multiply exponents here. 6 times a third, the 3's will cancel, and you'll get y squared. And you still have times, you can drop off these parentheses if you want, x squared and y to the 1/3. All right, so for the last step, what are we going to do? So in the last step, here, you have a 2, and then you have x to the negative 1 and x squared. So what do you do with these exponents? Right, so you simply add them now. So this is going to be negative 1 plus 2, which is 1. And I know I'm going to add them, again, because if you take 2 times 2, I get 2 squared. So if these are both raised to the 1 power, so you didn't multiply the exponents, you added them to get the 2 up here. And then here, I'm going to have y, and then I have y squared and y to the 1/3. So now what am I going to do with those? Again, you simply add them. So you have 2 plus 1/3. You'll have to add this on the side. So you have to add 2 plus 1/3. So 2 plus 1/3. You have to get a common denominator. So remember, this is really 2 over 1. So you'll put a times 3 here and a times 3 here. So that's 6 over 3 plus 1 over 3, which is equal to 7 over 3. So this is going to be equal to 2 times x. You can drop off the 1 because that's implied. And then y to the 7/3. Just like that. That's my answer. All right, let's look at the next one. So on the next one here, instead of multiplying, you're dividing. And there are all kinds of things you can do here. Sometimes you work from the inside out. Sometimes I work from the outside in. Since these powers are fractional, I'll probably work from the outside in. So first I'm going to take care of this negative. So when you take care of the negative, it's actually very simple. What you're going to do is you're going to take this top and you're just going to write it in the bottom. All right, so this is still all going to be raised to the 4th power because I haven't done anything with that. But that top piece, you're just going to write in the bottom. So I have y to the negative 3/2. And then this bottom piece, I'm simply going to write in the top. Right, that's what the negative says. The top goes to the bottom goes to the top. So you just copy it down, x to the negative 1/4, and then y to the 7/4. Which is equal to then, so the next step, I'm going to work with this 4th power. So this 4th power, right, it will go through the division. So exponents go through division, just like here the exponent went through multiplication. And each of these things, this thing, and this thing, and that thing, are going to be raised to the 4th power. So it's going to be x to the negative 1/4, all raised to the 4th power. And it's going to be y to the 7/4, all raised to the 4th power. And it's also going to be then on the bottom, y to the negative 3/2, all raised to the 4th power. And so now I took care of the 4th power, and now I have exponents, exponentials raised to exponents. So what do? Just like you did right here, you're going to multiply the exponents together. So negative 1/4 times 4 gives you x to the negative 1. 7/4 times 4, again the 4's cancel, and you get y to the 7th. Divided by, here, negative 3/2 times 4, the 2 is going to cancel with one of the 2's here, so you're just going to get y to the negative 6. Right? So 4 over 2 is 2, and 2 times negative 3 is negative 6. The second to last step is basically you're going to take care of these negative signs. So remember, when you have a negative sign in the exponent, here it means just move it to the bottom. When it's in the bottom and you have a negative sign, you just move it to the top. So what we have here is y to the 7th divided by x to the 1 goes to the bottom, so it's just really x. But y to the 6 is going to go to the top. And then finally, here you have exponentials with the same base. So what do you do with these exponents? You don't multiply, you add. So 7 plus 6 is 13, and that's all divided by x. So that would be my final answer. And then finally, down here, we're going to work with the radicals. Now, working with radicals and exponents is somewhat similar in the sense that radicals also go through multiplication. So this is really, if you want, you'd say this is the square root of 320 times the square root of x to the 4th times the square root of y to the 13th. And the idea is to write everything in terms of squares. So for 320, I need to do a little bit of work because I need to see the factorization of this thing. So if you want, I'd probably just factor this in 2. So this is 2 times 160, 2 times 80. All right, so 2 times 40. There are a lot of 2's in here. So then 2 times 20, 2 times 10. Let's go down a little bit more here. And then 10 is 2 times 5. So what you have is 320 is 2 times 2. Let's color these. So you have 2 times 2 times 2 times 2 times 2 times 2 times 5. Or if you want, there's 8 times 8 times 5. So this is really equal to the square root of 8 squared times 5. And you can check it on your calculator if you want. So you can take 8 squared times 5. You'll see you get back 320. And then x to the 4th is really x squared squared. And then the square root of y to the 13th is really y to the 6th squared times y. Right? So the idea, there's 4 of these because you multiply. Here there's 12, and then you have y to the 1, so 12 plus 1 is 13. But you can pull out the square stuff. So this is probably the simplest or the quickest way to do it. And there are other ways that I showed you, so you can do it the way that I showed you, but this is probably the quickest. And so what I get is 8 here, square root of 5. And then this is a perfect square. So x squared squared, you just get back the x squared, times the square root of x to the 6th squared. So you can pull out the square stuff. So you can pull out a y to the 6th, and you're left over with the square root of y. So my final answer, you got to put the square roots back together. So you have 8x squared y to the 6th, 8x squared y to the 6th, and then the square root of 5, because that's still in a square root sign, and a y. And so that would be my final answer. Okay, and so we move on. And so down from 7, we move on to number 8. So on number 8, what we need to do is we want to rewrite using exponential or radical notation. So right here, this is in radical notation. We want to write it in exponential. This is in exponential notation. We want to write it in radical. So what we need to remember is that if you have anything to the nth over m to the n over mth power, this is going to be equal to the mth root of x to the n. And so right here you have x cubed, so that's always already written as an exponent, so you have to change that. But this, we're going to need to change as x raised to something. And x raised to what? Well, the 5 is the good thing, so it's going to go on top, so it's 5. And then divided by, and 7 is the bad thing, so 7 goes on the bottom. So the 7th root of x to the 5th is really x to the 5/7. And so it's equal to, now you're going to add exponents. So remember, I know that because 2 times 2 is 4, which is 2 squared. So 2 to the 1, 2 to the 1. So you add exponents. Same idea here. You add exponents. So that's x to the 3 plus 5/7. Now over here, I'll add 3 plus 5/7. And that's going to be equal to what? So I find a common denominator. That's really 3 over 1. So I multiply top and bottom by 7. And I get 21 over 7 plus 5 over 7, which is equal to 26 over 7. So that's equal to x 26 over 7. So that's my final answer. So I'm from radical notation to exponential notation or exponent notation. All right, now this one, I have it in this exponent notation, and I want to write it in radical notation. So what do I do now? Again, you have to come up here and look at this and realize there's a negative sign here. So we'll take care of that first, right? So the negative means 1 over. So 1 over x to the 3/2. And then we come up here and say, oh, n is 3 and m is 2. So this is really 1 over the square root, because that's what the 2 says. There's a 2 here. We'll write it for right now. We'll drop it off later. And then 3 is the good thing, so x cubed. Now this can be simplified, so we should probably simplify it. We shouldn't leave it as it is. So it's 1 over, and the way you can simplify this is a square root. X cubed is really x squared times x. And so remember, you always pull out squares out of the square root, so it's 1 over. So it's x squared, so you can pull out whatever's inside there, so that's x. And you have left over with the square root of x on the inside. And that's my final answer. So I went from exponential notation to radical notation. And the next problem, number 9, we're going to perform some operations using polynomials. I didn't put an addition or subtraction on here because you have to do addition and subtraction actually to do multiplication and division. So we'll practice that while we kind of go. Multiplication is actually very simple if you think about it properly. So you're just going to say x squared times this and x squared times that. So that's how you basically multiply polynomials. You just kind of use these arrows. When there's 2 and 2, you can use FOIL, but it breaks down in this case. So x squared times x is x cubed. And then x squared times minus 7 is minus 7x squared. So that's the first two terms. And then you do the next two. So this times this, and this times that. So negative 2x times x is minus 2x squared. And then negative 2x times negative 7 is plus 14x. And then we'll do the last two terms. So 3 times this and 3 times that. So 3 times x is 3x. So we have plus 3x. And then 3 times a minus 7 is a minus because it's plus a minus. So it's a minus 21. And then we simplify by combining like terms. So that's going to be equal to, there's only one x cubed term, so you just get x cubed. And then you have a 7x squared and a minus 2x squared. So minus 7 minus 2 is minus 9, so minus 9x squared. And then you have a plus 14x and a plus 3x, so that's plus 17x. And then finally you have a minus 21. And so that is my final answer. So let's finish up here on number 9 and do this division problem. So remember, when we're dividing two polynomials, you can think about dividing numbers like 3 divided by 2. And so 3 goes on the inside here and 2 goes on the outside. So on this one, what we'll have is we'll have x minus 2 on the outside. And then on the inside here, we'll have the 4x cubed minus 3x squared plus x and then plus 7. And so then divide polynomials is just like dividing numbers. You say, how many times is 2 going to 3? You say 1. You get a 2 here because 1 times 2 is 2, and then you subtract and you're left with another 1. So here, same idea. You want to see how many times this x minus 2 goes into this polynomial. So you look at x and you put a 4x squared here because 4x squared times x is 4x cubed. So you have 4x cubed, and then you have minus, because minus 2 times 4x squared is negative 8x squared. So remember, the idea is you take this times that, and you get this back, and then you're going to subtract off. So remember, you're subtracting the whole thing. So these will cancel perfectly, but a minus is a plus. So it's really plus 8x squared minus 3x squared, which is 5x squared. So again, watch out for that minus sign. It's a minus, which makes this a plus. So you have plus 8x squared minus 3x squared, which is 5x squared. You bring down the x, right? So plus x plus 7, and you start over. All right, so let's start over. So now I have to figure out, how many times this goes into 5x squared. And so we'll write plus 5x. And so 5x times x is 5x squared, which is good. That's exactly what I wanted. And then 5x times minus 2 is a minus 10x. And again, we'll do a minus and the whole thing. And so when you do this, what happens is the 5x squareds cancel. But then again, a minus is a plus, so you really have plus 10x plus x, which is 11x, then plus 7. And so this is going to be plus 11, because 11 times x is 11x, minus 22. Right? So 11 times x is 11x, and 11 times minus 2 is minus 22. You'll subtract again the whole thing, and you're going to be left with what? Well, 11x's cancel, but a minus is a plus, so you have plus 22 plus 7, which is 29. And so that's how we do the division. If you write out what it's equal to, remember over here, you have a 1 on top, so this really says that 2 is equal to 1 plus the remainder here is 1, so you have the 1 divided by 2 there. So right here, this will be equal to 4x squared plus 5x plus 11, and then plus the remainder of 29, that's divided by, here it was divided by 2, so here it's divided by x minus 2. This expression, 8x squared minus 2x equals a negative 6, not equals, but then minus the 63. So how do we factor this? We know it's something times something. Okay, normally we would write an x here and an x there, but the problem is if you multiply that, you get x squared, and you don't get 8x squared. So you have to factor 8. And two common factors of 8 are 4 and 2. So that's my guess. My guess is a 4 is going to go there and 2 goes there. Of course, 4x times 2x is 8x squared. But then I have to work with this 63. And so when I think of 63, what two factors come to my mind? Well, 7 and 9. So you have two choices. You can put a 7 and 9 here, or you can put a 9 and 7 there. All right, so I'm going to start with the 7 and 9 and see what happens. So what happens is that here I have 4x times 9, which is 36x's. And here I have 7 times 2, which is 14x's. And what I need to do is make 22x's out of basically 36x's and 14x's. So the idea is basically, can you make 22 by adding and subtracting 14? And it turns out you can. Right, so 36 minus 14 is 22. So you want plus 36 and minus 14. So my first choice worked. If that choice didn't work, then I would swap out the 9 and the 7. So I put a 9 here and a 7 here. And if that didn't work, then you'd have to come back to this 4 and 2 and redo it, because other two factors of 8 are actually 1 and 8. But it's usually the most common. So that's a factorization of this thing. You can, again, check your work. So to check your work, it's real simple. You take 4x times 2x and get ax squared. And then you take 4x times this and you get plus 36x. Oops, good thing I'm checking my work because I already see I made a mistake. But let's keep checking. So then minus 14x and then plus or minus a 63. Negative 7 times 9 is negative 63. Now I know I made a mistake here because I need to get negative 22, not positive 22. So good thing I checked my work, because that's going to flip these signs. So this sign shouldn't be negative. It should be positive, and this one should be negative. So this should be a negative here, and this should be the positive, and this should be the negative. Right? That way, what happens is when you check your work, this turns out to be the negative sign, because 4x times negative 9 is negative 36x, and this turns out to be the positive one. Right? So plus 14x. Right? So make sure you check your work, because it's easy to get the signs wrong. So negative 36x plus 14x is now a negative 22x. Right? So this would be my answer. All right, let's look at the last question. So this is solving equations. So how do we solve equations? We have a linear, a quadratic, a rational, and over here we have a radical equation. So let's solve the linear first. So in this linear equation, the problem really is you're dividing by 2, so we'll multiply everything by 2. So 2 times 21 is 42, minus x over 2 times 2, the 2's will cancel, so you get minus x, is equal to 3x times 2 is 6x. Right, so we can do what's called clear the denominators by multiplying by whatever's in the denominator. So this clears the denominators. We can add x to both sides. And when we add x to both sides, we get 42 on the left equals 7x on the right. Then we can simply just divide by 7. Since you're multiplying by 7, we do the inverse, you divide. And we finally get 6 on the left, because 42 is 6 times 7, so 7's cancel, is equal to x. So 6 is my x value. You can check your work by plugging in 6 here. Right? So 21 minus 6 over 2 is 18. And that should be equal to 3 times 6, which is also 18. So it checks. Right? So I know the answer is right. Over here, this is supposed to be a quadratic equation, so let's make it a quadratic equation. So this should actually be equal to 21. Let's say that's not supposed to be a minus; it's supposed to be an equals. And so, how do you solve this quadratic equation? Well, you take x squared plus 4x, and you subtract 21 from both sides. You get minus 21 is equal to 0. Right? So take away 21 from both sides. And now the idea is you can factor this. So this would be x plus or minus something times x plus or minus something equal to 0. And for the somethings, you're going to look at this 21. And the most two common factors of 21 are 7 and 3. It does not matter where you put 7 and 3 because these are both x. And you want to figure out, is there any way to add or subtract 7 and 3 and get a positive 4? And you say, yep, plus 7 minus 3. So this should do it. You can check it. You have x squared minus 3x plus 7x, which is positive 4x, and minus 21. So it checks. And so now this times that is 0. So either x plus 7 is equal to 0, or x minus 3 is equal to 0. And so we'll subtract 7 from both sides here. and get x equal to -7. We'll add 3 to both sides here and get x equal to 3. So you have two answers, x equals -7 and x equals 3. You can check your work, again, by plugging in here. So if you want on your calculator, you could do something like, oh, let's check if 3 works, okay? So you have 3 squared, so you do 3 raised to the 2, and kick it out, and then plus 4 times 3. And you should get out 21, and you do. And you can check it with -7 also, so left parenthesis, -7 in parenthesis, raised to the 2, and then plus 4 times -7. And hopefully we get out 21. If we do, we know we did it right. If not, we have to go back and find our mistake. So that works. All right, the next equation is what's called a rational equation because you have x stuff in the denominator. So it's like polynomial divided by polynomial stuff. And so how do we simplify this? Well, what you have to realize is that there's some answers for x that you know can't solve this equation. So some values for x, like x cannot be equal to 2. Well, why can't x be equal to 2? Because if you try to plug in 2, you get 0 on the bottom. X can also not equal -2. Because if you plug -2 into this, you get 0 on the bottom. Then over here, what you need to realize is x squared minus 4 actually is x minus 2 times x plus 2. So right away, I know that there's no other x values it can't be because these are the same things, x minus 2 times x plus 2. So what I'm going to do now is clear the denominator. So just like I did up here, I multiplied by 2. What I'll multiply by here is x minus 2 times x plus 2. And that's it. I don't have to multiply by anything else because x squared minus 4 is this. And now when you multiply through by this thing, over here the x minus 2's cancel and you just get x plus 2. Plus, right here the x plus 2's cancel, so you just get 3 times x minus 2. And right here, everything cancels, so you just get the number 4. So you take a rational equation and you turn it into a linear equation. And you just simplify a little bit more, so you have x plus 2, multiply through by the 3, so you get 3x minus 6 is equal to 4. So remember, positive 3 times -3 is minus 6. And so on the left-hand side, I have x plus 3x, which is 4x, minus, so plus 2 minus 6 is minus 4, which is equal to 4. Then I'm going to add 4 to both sides, and I get 4x equal to 8. Then divide both sides by 4, and so x will be equal to 2. So my answer would be x equal to 2, but make sure you check your answer, because on the rational equation, sometimes you do introduce a solution to the system that was not a solution to the initial equation. So right here, when you try to plug in 2, you realize you have a problem. You can't plug in 2 because 2 minus 2 would be 0. So it turns out that's not a solution. So you have no solution. All right, finally, let's work with this radical equation. It's called a radical equation because it has a radical. This is the cube root. So under the cube root, what do you do to both sides? You simply cube it. So we cube both sides. On the left-hand side, you get x squared plus 2x is equal to, and you cube 2, you get 8. You're going to subtract 8 from both sides, and you're going to get x squared plus 2x minus 8 is equal to 0. And so now I have a quadratic equation. So what we're going to do now is we're going to factor. So we'll have x plus or minus something times x plus or minus something equal to 0. And here 8, two common factors of 8 are 4 and 2, so we put a 4 and 2 here. And then you just have to figure out, is there any way to add or subtract 4 and 2 and get a positive 2? So yeah, plus 4 minus 2. And so now this times that is 0, so you know either this is 0, so x plus 4 is 0, or that is 0, so x minus 2 is 0. And so then we subtract 4 from both sides, and we get x equal to -4, versus we add 2 to both sides here, and we get x equal to 2. Again, you should try to check your answers to make sure they actually make sense. So, for example, on your calculator, if you want to plug in -4 and you want to do the cube root, remember that's actually raised to the 1/3. So what I would do is left parenthesis, -4 raised to the 2 plus 2 times negative 4, in parentheses, then raised to the 1 divided by 3. That's the third root. Hit enter, and if I get out 2, which I do, I know it's right. And you should also check 2, but if you check 2, it'll also say it's right. So now I know, well, I guess I check down here. Those are actually good solutions.